So welcome to today's webinar, LoRaWAN, a digital revolution for oil and gas, by the Smart Industry Workgroup of the LoRa Alliance. Some background on Entelec for those of you that are new maybe to this association. The Energy, Telecommunications and Electrical Association was launched in 1928 to serve the burgeoning energy industry. 92 years later and still going strong as a user association, focused on communication and control technologies used by petroleum, natural gas, pipeline and electric utility companies. The Regulatory and Technology Committee was formed to press on regulatory developments for the interest of the members and to be able to provide educational content and technical presentation and panel discussions, much like this one today for its members. Reporting to the R&T Committee is the Industrial IoT Subcommittee, chaired by myself, Daniel Quant, and Billy Hayes from Williams, and is a broad industry engagement focused on digitization best practices for the members and their organizations. The Entelec Industrial IoT Committee is excited today to be able to introduce this webinar from the LoRa Alliance, a technology association that develops and maintains a global open specification and certification scheme for LoRaWAN, a revolution in asset monitoring and digital transformation for oil and gas segments, moderated today by Philip Deroux from Chevron. And please remember, type in any and all questions that you have in the Q&A window. Don't be shy, and the panel will answer them later on in the webinar. Over to you, Philippe.
Thank you, Daniel. Yes, so and additionally to that, I mean, we plan on having enough time at the end to answer some questions live as well. So please feel free to use both the chat and ask questions at the end. Anything you want to talk about concerning LoRa. So I'm very happy to introduce Scott Cubes from RBWise, Josh Cox from Oxit, Robert Ward from Multitech, and Jonathan Polly from Chevron. They are the panel member, and they're going to provide their insights on LoRaWAN for the oil and gas environment. But before we go there, I will provide a bit of introduction for people that are not familiar with the LoRa Alliance. So the LoRa Alliance is an open non-profit association that was launched in 2015, and it's really focused on standardizing the LPWAN, low power wide area network. And there are several protocols for LPWAN, but really focus on the LoRaWAN protocol. So the goal is really to develop and maintain a global open specification that's accessible to everybody, and to work on the next generation, making it even better after each revision. So the other role also that's very important is to provide a certification on sensors and gateways, and that's being done through the LoRaWAN Alliance to support that. So as you can see from this slide, the LoRa Alliance is growing. There are a lot of members, and it goes from the sponsor members to the contributor members to the adopters and institutional members. A lot is happening in that space because of the flexibility of LoRa and LoRaWAN environment. So if you look globally, the LoRaWAN has been adopted and already implemented in about 161 countries worldwide, and lots of activity in that space. And there exists currently 143 LoRaWAN network operators, and it can be public operators or private operators. So what is LoRaWAN? So LoRaWAN is really based on a technology, and it goes, if you look at the ecosystem, it goes from the chipset all the way to the integration and solution. So you can go from the field sensor all the way to the cloud implementation, and having a review of the data from the operator in the field environment. So the chipset is the important part of it, that will the silicon-based environment that support the LoRaWAN standard and the LoRa modulation. From the chipset, different manufacturers build modules. From those modules, you can also build devices, and a lot of them would be sensors. And depending on the type of sensor, you can interface different types, could be, and I will talk a bit more about that in the next slides. But it's really, really flexible, and really the LoRa allows you to send data according to the data you're getting from those sensors. So those devices, the sensor talk to gateways, and the gateways on the LoRa protocol, and the gateways go back to the servers where you do the analytics, and it can be run by operators and be put either in a cloud environment or on-prem environment to support your requirements. And there are multitude of solutions that are developed depending on the use cases. And you can work with system integrators if you have specific use cases to develop new solutions for your industry. So currently, if you go to the LoRa Alliance website, you will see 6 verticals that really have been focused on. So the smart cities, building automation, industrial IoT, utilities, agriculture, and asset tracking. As of today, there are millions of LoRaWAN connected devices. And we expect, because of the specificity of the LoRa, which is really in the low power, long life battery, small data messages, and deep penetration in building, that the market will even grow further. Of course, everybody's talking nowadays of 5G. 5G is really a different environment. 5G is more for low latency, high bandwidth requirements. So sensors that really need to send a lot of data, or sensors that really need a very low latency. That's really not the space for the LoRaWAN. LoRaWAN is more like a little bit of data, but wide area coverage, right? So this is the information. So the next slide, this slide is really to talk about the technical side of LoRa for people that maybe are not aware of it. So LoRa is a LPWAN, low power wide area network technology for low rate, a few kilobits, long range communication for IoT device. It's in a license-free ISM band, industrial, scientific, and medical, sub-gigahertz radio frequency. So if you look at this slide, it gives you an idea of which frequency are used in Europe. So 868 megahertz, 433 megahertz, in the US 915, Asia 430. So if you go to the LoRa Alliance, it gives you an idea of which frequency you can use for your environment. It provides bidirectional acknowledged communication in a very simple star network technology. It provides LoRa modulation. That LoRa modulation is based on chirp spread spectrum technology. So it's very, very reliable and really can deal a lot with interferences. It provides accurate localization. So again, when we talk about accurate localization, you need at least 3 gateways to get the data from the sensors. And accurate, it will not give you GPS accuracy, but in some application is more than enough. We're talking about 60 feet to 20 meters. So the sensors and gateways are really low-cost sensors designed for long battery life, and that's really important to look at the fact that the sensors and gateways are really inexpensive, and you can put them and they would cover a wide area. In terms of security, it follows 802.15.4 with AES 128 encryption. And sorry if I'm a bit technical. This slide is really technical. And really, for me, the big advantage of LoRa is it's built on an RF link budget of 154 dB. In the US, depending on which country you operate, but it's between 150 to 154 dB, which means you have a lot of capability to send data, even in very noisy environments. There are different classes of data transport. The first one is a class A, which is a baseline. Class B is more like a beacons type environment, and class C is continuous. Of course, as you move between the classes, you will need to be operating longer. So a class C will not, a sensor will not last 10 years, where in a class A, it would. So now that we understand the technical capability of LoRaWAN, I wanted to give you a bit of feedback of what we expect or what we see for the oil and gas industry. So of course, I mean, when we talk about LoRa or about sensors in the field or gateway in the field, we need to look at the oil and gas requirements that are very specific to our environment. So the first one is ingress protection to be able to be put in the current environment. Wide operating temperature. I mean, I know some countries you go to -40 to +40 degrees C or -40 to 140 Fahrenheit. I think that's what it means. You have some environment where you do put sensor in hazardous area. So it could be a class 1 dev 1, class 1 dev 2, zone 1, zone 2, ATEX, for example. Very important as well to look at the power consumption in terms of battery or wired for power consumption. Sometimes solar panel would do the trick. Cybersecurity. Everybody knows that every time we put something in our environment, we want to make sure it's very secure and nobody can hack into them. And really also looking at is installation, monitoring, and maintenance environments. At the end of the day, it's always the same thing for us to be safe and to have the right cost environment for in terms of CapEx and OpEx. So what are the typical use cases for the oil and gas? Mainly, it's what you would see like in a SCADA or in a PCN environment, but more on a IoT space, right? So you would not be in that PCN, but you would still get data to be able to do a digital twin and get more data from your environment and be able to better understand your system and processes. So for us, it would be pressure, temperature, location, any type of some type of vibration. The other use case for us are equipment and personal safety tracking, like vehicle, when you're on land, vessel tracking when you're offshore, be able to have and monitor a lone worker, making sure everything is okay. Sometimes there's no other means of communication. There are areas where cellular is not, you don't get connectivity. So either you rely on VSAT or LoRaWAN, for example. Being able also to do remote site monitoring, and that will be access control, making sure that everybody or somebody coming into your site would have the right to enter your site, or look at environmental status. I mean, some areas are very remote and you could be in a snow environment and you don't have access. So you want to make sure that it's operating in the right environment. HES as well, again, field worker, soil monitoring. Really, I mean, all those hard to reach and monitor area could be swamp, it could be offshore. The other thing I would say as well in the process area is a bit different because again, that's 150 to 254 dB capability allow you to go further and get data where you have a lot of structure that typically wouldn't be reachable with other sensors. So at the end of the day, what you're trying to see is to put not too expensive sensor in your environment that will give you all the data that you need to make the right decision and to support the field worker and your company in that environment. So I talked about it already a little bit, but really, I mean, what are the differentiator and benefits from the LoRaWAN? The first one is it can be put in a public or private deployment, so you can do it yourself, or you can work with an integrator to do it for you. It has a capability to do firmware updates over the air, so you don't have to go each gateway and update it manually. So it saves a lot of maintenance capability. It provides geolocation capability with triangulation, RF triangulation. We talked about it as well in terms of security. It has a AES 128 encryption. For sensors that are running in class A and only send data like once a day or twice a day, you can expect up to 10 years of battery life. And it provides coverage in rural and non-cellular area. I already talked about it. I mean, it exists. There are some area even in the US where you couldn't get any cellular coverage. And the big advantage as well is a deep penetration on a structure like concrete, ground, steel. So this is why, I mean, LoRa has been, deployments are scaling up and are massive. And it's becoming de facto standard for the low power wide area network environment. So this was a quick introduction. Now I'm going to pass the information to Scott Cubes from Orbywise. Scott,
Oh,
you go.
thank you for the kind introduction, Philippe. Hello, all. My name is Scott Cubis. I'm head of business development and sales and other things for Orbywise for the Americas and Australia, New Zealand. A little bit. There's some details on the slides, and I know this will be shared, so I won't spend a lot of time on that. But we're suppliers of one of the most versatile and well-supported LoRaWAN network servers, which we'll go into in a little more detail in terms of what that means in a network structure. So the thing I'm going to focus a little bit more on is some of the lessons we've learned with whether it's our good partners at Chevron or Rigstar, and we've got 8 other commercial trial or POC activities going on with other oil and gas companies as well. But we're based out of Geneva, Switzerland. And like I said, our core product is the LoRaWAN network server. Honestly, in looking at oil and gas, we're seeing activities really in 6 of the 7 continents, and we've got activities going on, I think, in 5 of those, and talking about in the 6th as well. And this ranges everything from the upstream to midstream to downstream. So it's in oil platforms like Philippe is standing on right now, and to oil fields, to refineries, to the pipelines, and everything in between. Philippe discussed a little bit about some of the solutions, and I can kind of mention that again, that we're seeing things such as metering, pressure remote pipeline riser monitoring, pipeline monitoring in general, or with PIGs, temperature measurements, pond level management, valve monitoring, asset tracking, even monitoring the boundaries on facilities, facility monitoring, and there's even more in development. So that the use cases are really endless. The thing to keep in mind, as Philippe had mentioned, is that LoRaWAN is a low data rate solution, but low power also. So it's really ideal for a lot of these, particularly use cases in remote areas where obviously oil and gas touches a lot. And so I'll talk a little bit more now. If you can move to the next slide. Yes, thank you. So basically with LoRaWAN, the traditional network, and so a few years ago, when people would throw up a map of the structure of a gateway, you have devices, your sensors talking into the gateways, which then in turn talk to the LoRaWAN network server, which is what we supply. So you see the OrbiWAN there. And then finally into your applications or application platforms, which are doing your data analysis and giving you all that wonderful, useful information to be able to help your operations. And this works really well in an environment where you have easy access to the cloud. But obviously, when you move into remote areas, it presents more of a challenge. You know, in terms of the devices and gateways, we have our good friends on from Chevron. So Jonathan can talk a bit about some of their devices. Josh can also talk about some of the work that they're doing there. And then Robert with Multitech can certainly talk to both devices and gateways. So the nice thing about the Alliance, you saw the members, there are a lot of good options and good suppliers for all of the elements that you see here, whether it's devices, gateways, the network server, or the application platforms. And there are other elements to the network as well. We may not get a chance to get into that today with all of the limited time, but anyway, to the next slide, please. And this is the one I really wanted to spend more time about, which is considering the fact that the network setup in many instances for oil and gas is not like the traditional network. And so I'll call it Edge, and we've actually got a LoRaWAN network server as part of our family of products called OrbiWAN Edge now. That these are servers, this is designed for networks that are operating on the edge, kind of standalone networks that really either don't have a connection into the cloud or can't have a connection into the cloud, or you don't want to have a connection into the cloud. So it's a standalone network. So once again, I mean, the devices and the gateways are kind of similar in terms of their communication. The servers, whether it's our Edge solution, Multitech also offers a Lens solution, which is based on a gateway. I think CareLink also has their own gateway solution. So there are some solutions there that are more locally oriented. And then of course now, you know, you can either do a scaled down application server or your base applications. And then you see the links back into the cloud are kind of an optional thing if you're able to do that, or you want to enable that. But the idea is that you're keeping the functionality of the network at the local level. And that can present a lot of challenges in times, not anything insurmountable, but as Philippe had mentioned, you know, you have different regions. We talked about 6 continents. So South America has a different frequency plan than say North America, from Europe, and from Asia. So you need to be considering that. And then you have the location of the network, the environmental issues. I know one example of somebody we're contemplating a POC with is looking at setting up in a jungle environment. And you have considerations on the forest, the leaves on the trees. And this has a very, very, you know, a big impact that you need to consider in terms of when you're configuring your network. You know, how do you account for this in terms of the loss and sensitivity for the network due to that? And once again, these are things that certainly can be accounted for because of the nice capabilities of LoRaWAN, but you know, you need to mind that. Philippe also touched on like power supply. If you want to do, if you don't have a, you know, readily available power source, then you have to look at solar or other means to particularly, and that is one of the characteristics of LoRaWAN is the ability, the low power capability of the network. So, so really seeing a lot of interesting use cases for oil and gas popping up in either very remote places in northern Canada or in Asia or in Africa, South America. And, you know, you need to consider all the points that you see here. And typically these are smaller to medium-sized networks. You have the same main elements. You do need to consider your local server you'll be running your network off of. The fortunate thing is you've got a lot of good people on the call here. We all understand LoRaWAN quite well. We've worked with oil and gas in this space. So if you have questions, let us know and we'll be glad to help you. And with that, I think I am handing off to Josh. Is that correct? Yes.
Yep. Thank you.
Very
Thank
good.
you, Scott.
Yep. Thank you.
Josh Cox from Oxit.
Perfect. Thanks for having me today. I'll start off with a brief on who we are and how Oxit enables success within IoT. Oxit's an IoT engineering services company. We primarily focus on 2 verticals. One, custom sensor development to solve those unique challenges when you need to capture the right data, and system integrator. So using off-the-shelf components to not just capture, but analyze and react to data to create value. 7 years ago, I was the crazy engineer pushing LoRaWAN. We did a deployment in Nairobi, Kenya. Actually, I was on the ground there deploying Multitech gateways. And I was very impressed just how we were able to cover an entire settlement with just 2 gateways to be correct, and cover, you know, thousands of homes there. And I really see an interesting parallel there to the oil and gas industry here, where in that particular solution, the sensors that we deployed, the batteries that went in them, were more than what a day's income there in that particular area of the world was. And so it was a lot of theft. And I know in talking to the oil and gas industry folks that we have, that's certainly a place of contention here, an area to be addressed. And so I think with the ability to do asset tracking and things like that, it's a wonderful technology. So we've deployed hundreds of thousands of sensors across hundreds of products. And today I'm just going to go through how we at Oxit leverage LoRaWAN to be successful in the oil, gas, and in the energy industries. Next slide, please. So how do you succeed with IoT? Really, for us, the goal of that is making sure that the cost to capture the data, is certainly in line with and less than the value we can create with the data. So in particular with oil and gas, though, there's a real opportunity for actuators. So being able to use data collected to react to that data in real time out there in the field. So cost to capture is everything from the infrastructure and maintenance to the sensors. So this is a place where LoRaWAN really shines due to just the range alone being miles. Less gateways means less infrastructure as well as less maintenance. So beyond that, just looking at the diverse set of sensors, though, that we get from using a open standard protocol like LoRaWAN, we're able to create that value effectively. So types of data we can capture, it is already indicated before, but for us, they typically bounce around pressure, temperature, vibration, dangerous gas levels, or whether or not a machine's running or not. And we can use those values to control a host of devices, whether that's valves and relays. So we go through, we minimize the cost to implement that infrastructure, and then we focus on the value we can create. Perhaps that's improved safety or in faster bounce back when there's some type of issue because we have infrastructure monitoring. So simply put, make sure the value that we capture outweighs the cost to capture it. So what's next after pricing? For us, we really want to make sure we move that aha moment before we actually deploy that first, those units. So we get past the pricing, we get past the cost and the procurement. For us, the two ones that we see is the security and future-proofing. So even if it's an off-the-shelf temperature sensor or a custom solution for pressure monitoring or some type of photoelectric sensor for detecting particular sizes, we just want to keep our eye on these security and future-proofing problems and solve them early in the process. So look, for us, a way of attacking that is through standardization. So we can kind of punch a hole right through all of these gotchas, if you will. Next slide, please. So I kind of briefly hit on why I like standardization so much. It's really staying away from those proprietary protocols. When you use this standardized protocol and things of that nature, you get massive amount of volumes out there because people are using these same devices, and that drives the price down. And then, as we said before, there's lots of vendors making devices. You also get competition, which continues to drive that price down. I reflect back on probably 2 decades ago when every cell phone had a different charger. And now they've kind of standardized, and we can get those chargers for about 1/10 of the cost. So ultimately, standardization leading to that better ROI. The next for us is security. Next slide, please. So how do we quantify the total cost of ownership as it relates to security? Really, we think of the TCO as directly tied to our exposure to risk. Interesting for the oil and gas industry, you can also think of security as infrastructure security as well. So we want to be risk tolerant and we want to understand our exposure. We also need an end-to-end mindset. So we're starting at the factory and we're thinking all the way to these devices being deployed in the field with remote and physical attacks as well. So minimizing our vulnerabilities we're exposing ourselves to ultimately reduces our TCO. So how can we do this and what are things we can implement? Firmware over-the-air updates is a big one for both security as well as bugs. Another fun one that I like to talk about is sensor fusion. So we can take 2 different types of sensors and combine them to reduce false alarms. A great example of this is one of our clients who has about 1 million sensors deployed to protect infrastructure out there for doors. We want to know if they're open or not. We get about 3,000 false alarms a day. So we really look at sensor fusion as a way to reduce those amounts of false alarms and things of that nature. The other areas we can push forward on is self-protecting software, avoiding simplistic solutions like blacklist updating, and doing all this while ensuring that we're not impacting the performance negatively. Next slide, please. So the fun one for me is thinking about future-proofing. There's a lot there. And these will kind of echo on the previous things I've mentioned. I'll start off with the vendor lock-in. So again, avoiding those proprietary protocols and trying to be as versatile as we can with our approach. I think the RF tech future options is a big one. I've seen some interesting solutions coming out as of lately, so that, you know, within this industry, we typically don't think just 10 years out. We think 20 and 30 years out. And so we want to have the radios and things in place. I call them flexible radios, or quote unquote SDRs, so that we can be able to address those concerns long term. We also have infrastructure cost, as I mentioned, the firmware over the air updates, and sensor lifetime, which always just isn't battery consumption. It can deal with memory and read and write limits and things of that nature. And lastly, I'll mention the kind of hubless deployments that are happening. We're seeing a big push for publicly operated networks with Amazon Sidewalk as well as Helium. And there's a lot of carrier grade networks being deployed in the US well, which is overall going to reduce our infrastructure costs. Lastly, I'll mention one of our clients we've just recently rolling out a product with. It's a natural gas detector. CNI Guard is focused on vital sectors like energy, electric, water, and transportation. And for this particular device, we wanted to be best in class with power consumption. We wanted to lower the explosive limit for the device while not triggering false alarms, and certainly pushing through the compliance and regulations issues that come with a new product in this field. Doing all that and reducing the operating costs to make it attractive. I've dropped our info in the left corner there, and I just want to thank you guys for having us.
Thank you, Josh. Very interesting. Thank you. Now we go to Robert Ward with Multitech.
Hey, good morning. Thank you. Yeah, you could go ahead and hit it one more time there, Philippe. Thank you. Yeah, so Multitech is a 50-year-old company based in telecommunications, which is kind of hard to think about, that telecom's been around 50 years. But really focus on the embedded LoRa modules and then a range of gateways, which really enable the foundation of any type of a LoRaWAN deployment, as you can see here. Next, please. So some of the things, when you start thinking about LoRaWAN sensors or wireless sensors and LPWAN, a lot of times there's confusion and, or, you know, where's the line with some of the stuff that's already taken place today? It's kind of like IoT and SCADA, right? What's the difference in some of those? But some of the sensor technologies that you might be accustomed to are like wireless HART or some of the proprietary 900 megahertz networks, which are deployed quite common in upstream oil and gas. And this is just kind of drawn a comparison. So the range of LoRa for an urban environment is upwards of about 3 miles, and then stated as 12 miles where you have good line of sight. And we know some applications that even go beyond that. So the topology and the reach of a LoRaWAN sensor network is really quite different than what you might be accustomed to with some things you've already deployed. Next, please, Philip. So when you start out and you're looking at this, there's in the previous years, because I've got 20 years in the wireless sensor space, and there's a lot of reluctance because there's so many disciplines that have to get involved with determining the sensor. What's the sensor going to tie into? How am I going to power it? Then somebody has to determine what's the field communication network going to look like, and how do I get that data point up? Is it going to be Modbus, or is it going to be something different? How am I going to get that into SCADA, and then get that data so that it's made available so it can be consumed for people to make decisions? That's the end goal, right? So you can see kind of on the left side here, we're going from a sensor up through a gateway and then injecting that data, making it available for consumption without having to engage everything that's kind of in the bottom part of that pyramid. There's also some pretty compelling reasons to be able to go around. You see the firewall indications there, and being able to kind of process or bypass a typical process control network really creates a lot of efficiencies and accelerates data availability as well. Next, please. So here you see a gateway being stood up out in the field, and I mean, that's really what you do. You can stand up a gateway, and as far as you can see, you can pretty much pick up sensors. And when you're looking at sensor or node consideration, there's a lot of built for purpose devices. Like you see on the bottom left on that chemical tank, that unit is built for purpose. You'd be hard pressed to find another application for that. The devices you see over on the right-hand side, those are kind of universal devices that use today's instrumentation, like you see the brands across the bottom there. So those type of universal traditional sensor nodes really accelerate the adoption and overcome a lot of the mindset of moving to an IoT, because these are such trusted brands for those particular process variables or control applications. Anyways, once you have that selected and deployed, those devices communicate up to the gateway, and then from the gateway, it's typically MQTT that the data moves out. We also recently just have a gateway available with Ignition Edge for Spark-Plug-B connectivity. And then that can connect either to, like Scott was talking about, an OrbiWise type cloud or a Multitech Lens private LoRa network server deployment. Next, please.
I think that's it.
I think
Robert.
that's it.
Yeah.
Yeah.
Thank you very much. Very interesting. So now we move to Jonathan Polly with Chevron.
Thanks, Philippe. Hi, my name is Jonathan Polly. I'm the Surface Digital Advisor for the San Joaquin Valley business here in California. It's one of several upstream business units Chevron has around the world, but we've kind of been on the vanguard for LoRaWAN within Chevron for some time. So I don't have anything to market here, but I do have some stories to share, and hopefully that can serve as some inspiration for this audience. This title slide, if any of you have happened to see that, if you could step back real quick, Philippe.
Oh, sorry.
That is our Kern River oil field. And I first saw that 15 years ago when I was an intern and had to pick my jaw up off the ground. When you see that kind of density, the amount of equipment, whether it's, you know, water treatment, power generation, you've got 12,000 wells very densely, you know, packed into a small area. We've been running that field for over 100 years. And it's just an arena ripe for the deployment of lower cost IoT solutions. We've been doing RF and instrumentation for, you know, 40 plus years, even with wireless. But to kind of dovetail what Robert was talking about, even Chevron's now kind of created that blessed path to go from the field to the cloud for lower consequence measurement. So all of the stranded value, you can kind of see it out there. It's just, you have your plants, those have been well instrumented for a very long time. But there was all of these routine duties that people were driving around the field, having to check a temperature, check a pressure, take a dipstick, measure a tank. That are now very accessible from an economic perspective, kind of that value cost trade-off Josh was even talking about. You know, this paradigm shift into LPWAN is really compelling for us, particularly in this asset for Chevron, where we have so much legacy, and it's kind of like the iconic brownfield when you think of it that way, literally in this picture. If you can go ahead, Philippe. So just a snapshot of our thinking. You know, we started this probably about 3 years ago when we got requests from our operators to automate some of their processes. They were going to thousands of tanks. They were taking measurements, like I said. And, you know, in the back of our mind as technologists, we knew that there was this emerging space in LPWAN, and LoRa was one of them. We'd look to Europe and to other industries to kind of understand, what are these folks doing out there to make this technology accessible, to make it very simple to deploy. We took inspiration from Europe, the way they collected trash and how they could deploy sensors very easily. Disney World was doing something similar for their 3,000 trash cans around the park. So we kind of had to look outside oil and gas to see what was going on, particularly in the US, because LoRaWAN was a bit of a slow start. Just like Josh's story, it was off in Africa, but we couldn't really see it here yet. So we started our investigation, and you know, kind of the executive pitch we made when we started to see the opportunity frame up was, you know, what if you could have a device that had a range of 5+ miles, that had a battery life of 5+ years and could cost $500? What would that change in terms of how we instrument and what we could instrument in the field? And that just blew open this queue of opportunities we have in that field that you saw earlier. And so we set off with kind of some thinking and exploration around, well, what do we need this network to look like? How can we deploy it? The snapshot on the right is a satellite view of the Central Valley of California. That field I showed earlier, Kern River, is kind of off in the right corner there, just for a sense of scale. But we have 6 fields like that throughout the Central Valley of California. And that was a simulated coverage map we saw we could produce with just a very simple deployment of about 30 gateways, incredibly low cost. Cellular backhaul made it very easy in terms of you know, connectivity. And so we set off to build this about 2 years ago with partners, many of them on this phone call. But yeah, just, you know, we knew we wanted to own the core. I think that was a key message. You've got a broad ecosystem of devices, a broad ecosystem of applications and cloud providers, but we wanted within our business unit to own that core and make it reusable, because we saw a trend of everyone bringing their own turnkey solution, kind of walled garden solutions. We wanted to own that network server, the gateways, and be able to create a plug and play model. So whether it was tank monitors, temperature monitors, we could rapidly introduce them from a broad ecosystem. But that's the part we wanted to own. And really, we were stubborn on the open standards, trying to steer away from proprietary solutions. The other key message I wanted to make here was we saw these devices as being consumables versus assets. A traditional kind of Rosemont or Emerson gauge, a very expensive device, costs a lot of money to deploy. These devices we see as being, if it breaks, it's a non-event, replace it from the warehouse, put a new one on there. A mobile phone, give it to an operator, and they're empowered to do that. That's a new paradigm with these devices, to where failure can be rapidly addressed instead of punching out a work order, and could be done in the same day. Next one. And so I'll focus on kind of our first large scale use case that we can speak publicly about. This was our chemical tank, our chemical management program in the Valley, where we had about tens of millions of dollars in chemical spend annually for emulsifiers and corrosion inhibitors and things of that nature to treat the wells. So you had about 3,000 of these little totes hanging off the back of wells and elsewhere in the field. And so that was our first opportunity. We worked very closely with our chemical vendor. We actually patented a lid design. We worked through that innovation process with them. We came up with a solution. All in, we were able to get about 30 gateways and 3,000 devices out into the field in about 6 months, which for oil and gas, and Chevron in particular, is light speed. Other industries, maybe not so much, but we were pretty proud of it. And that's been online for about a year now. We've seen tremendous value from that activity. Kind of a key anecdote I wanted to share at the bottom there was when we had to fight for funding to kind of keep this going. One of our operations leaders kind of made the pitch. He's like, there's no well we could drill in this valley that had a higher ROI than this opportunity. And with that, we were able to get the limited funding we needed. We didn't need much to do this. And spin it up and get it on its way last year. And so, yeah, we're very much looking forward to seeing, okay, we have this network, we have this plug and play model. The Valley has coverage that was incredibly inexpensive. Now we're working closely through the Alliance and these partners to kind of continue to grow on that momentum. So thank you very much for giving me the opportunity to share with you all today.
Thank you, Jonathan. Very good information on what has been done and what we can officially talk about, right? Okay, so if you want to get more information about LoRa, the LoRa Alliance, here is the link to the website. And this link in particular will give you access to the different vertical market we talked about. If you want to contact, here are the information, the LinkedIn, the website, and the Twitter account. And now is the right time for Q&A. So here is the name and the presenters, and the panel presenters. So feel free to ask any question. I saw there was one on the chat about any vendors with LoRaWAN devices in a lone worker space. And John gave some feedback. Scott gave some other feedback. Anybody else want to maybe chime in and give more feedback on the lone worker capabilities?
I mean, we've certainly used the ABWay on our side. They also have an SOS, which has a small button on it as well. So I've seen those be effective. And then I think it's also worth mentioning Semtech's just releasing their LR1110 solution, which I don't think is in these trackers yet, but is coming soon, which will further reduce the unit cost of these devices. So pretty exciting stuff.
And I can put a slant on that. We came across the ABWay device really in the midst of the pandemic in terms of contact tracking and trying to see what options were out there. And ABWay was being pitched as one of those options. But asset tracking in general is a massive opportunity for oil and gas. And just like Josh was saying, that new Semtech chip and its profile and characteristics are going to really unlock a lot of new asset tracking opportunities at really low cost.
Very good. Thank you. So another question for the panel participants. I mean, we talked about ROI, right? Return on investment. Can anybody chime in, explain what it means in terms of CapEx and OpEx?
I mean, I could take it if you'd like. We generally, for us, as far as raw cost and looking at engagements, Typically, a proof of concept is anywhere from 1 month to 6 months. I mean, you can certainly get POCs up in a day, but they don't generally create real value. I see most of our opportunities getting ROIs within less than a year, which I think is just amazing, from a deployment standpoint. But I don't know if that provides enough clarity. Maybe someone else wants to chime in.
Yeah, I can echo that. I mean, the value that we saw in the first year of that program, I can't give specifics, but it was an order of magnitude over what our investment was. As a rule of thumb, kind of when I'm internally talking about these new approaches, you're almost looking at about 1/10 of the cost of a traditional instrument. It's not so much on the CapEx or the cost of the hardware. It's the electrician, it's the engineer, it's the highly skilled labor that needs to be involved to care and feed for it. We had gone through an exercise to use traditional approaches for instrumenting these tanks some time ago, spent a lot of money, but they would fail. And then it required a work order and an engineer, and it would never get prioritized. Before long, half of them had failed and were just simply not fixed. So the OpEx side was actually the bigger opportunity. That point I made earlier about failure not being an issue. You can just hot swap these devices much easier than traditional automation techniques.
Okay, thank you, guys. So there's another question. It's a little bit different from Laura, but it's interesting to answer it. I mean, what is the challenge to get LTE coverage for backhaul in the San Joaquin Valley, California? So it's mainly looking at how you bring that data back, right?
Yeah, good question. I mean, that was why LoRa was explored, was because, if you're in a city and 5G sounds great, if you have coverage, we're not going to have it. So LoRa has been very effective at getting into these little nooks and crannies in our field. Backhaul for us is still, we can use the cellular networks, but even that can be a challenge sometimes. There's an area that we're really interested in, and that's when you start to pair this technology with satellite backhaul and low Earth orbit satellites, things of that nature. That really means you could put this anywhere in the remote tundra up north, or on a ship on the ocean. It becomes very flexible.
That kind of chimes into what I was talking about, which is a lot of these cases, like San Joaquin as an example, you keep your network local and you don't necessarily have to connect back to the cloud. But we've done some testing with a couple of different satellite solutions for backhaul, and it works quite fine, assuming you've got the appropriate even satellite coverage. Not every place is covered by satellites, or it's only covered by a particular satellite operator. So just some things to keep in mind.
I'll add on to that, Scott. I don't know if it was what you were aimed at, but it's interesting too that there's some LoRa-based satellite options, as well as satellite just standard kind of connectivity. So we've got a lot of interesting innovation happening in the space. I do think it's somewhat of a moving target, but I do think you can safely deploy LoRaWAN today and know it's going to be in place for 20, 30 years. The question is there's so much innovation happening right now. It's kind of a fun time to be dabbling in this space, I think.
Yeah, I think to Scott's point about network segmentation and the ability to deploy independent of the cloud, early on in our evaluation, that was a key feature we were looking for. And that's another area where it's very flexible. Yes, you can use the monolithic server in the cloud if you like, but you can also carve it up and put it into isolated networks. And we're not doing it yet, but you could see it making its way into some of the legacy environment in time. But that ability to kind of plug and play and pull apart and move the architecture to where you need it, given a certain use case, it's very adaptable.
Yeah, that's actually an excellent point.
Okay, lots of questions coming our way, guys. So another one, has CBRS been looked at for wireless connectivity, especially in higher speed application needs?
I'll take that one, Philippe. Yeah, so Multitac, we have three different CBRS end devices. So there's one that's really quite simple. Then there's one that's and one with a little bit more routing capability, and then a full-blown router. And anyway, so those devices could be connected to a gateway. I don't know that we have anyone that's deployed that yet, but it certainly makes a lot of sense. And with the recent license auction of CBRS, we certainly have a lot of dialogue going on in that space. So I wouldn't be surprised to see it pretty quick.
Yeah, and again, I mean, you guys are looking more at the gateway side of it, where you put LoRa device talking to a gateway, and the gateway send it over the LTE. It could be CBRS, it could be a public carrier, right?
For sure.
Yep. Okay. Next question. What is the comparison contrast of LoRaWAN with 5G's future massive machine type communication, MMTC, which is intended for connecting to IoT sensors?
You might unmute, Daniel.
Yeah, sure. I'll take that one then, I guess. So let me put my video back on there. Right, so look, what is 5G, right? 5G is enhanced mobile broadband, it's low latency, it's critical communications. LoRaWAN, on the other hand, is almost a dipole opposite. It's about finding the most optimized range versus battery budget to be able to provide a huge density of endpoints out there. If you look at 5G, its answer to massive machine type connectivity is CAD-M and narrowband IoT on a 4G radio. So not to say that that won't scale, but I think what you'll see a lot, particularly in industry where networks like to be privatized and capitalized, I think what you'll see is 5G being used for mission critical low latency backhaul on gateways connected to LoRa that then are providing you the true massive machine connectivity of endpoints.
I think there's a real OpEx point in there too, because the 5G networks and the connectivity and the cost there, to me, it's a fraction of the cost comparatively when you look at operating, when you're trying to consume over 5G. But to me, they're just two different technologies and two different use cases. So it's all about finding the right solution for the right job. So.
Yeah, and more importantly, Josh, when you put the two together, you have all of the best KPIs for your solution approach. You have the backhaul, you have low latency, but then you have the density and you have the range and battery budget trade-off. So really the two together are incredibly synergistic.
I think the battery dimension gets overlooked often in the cost and range discussion, but that's the other thing you have to keep in mind. If it's a cellular modem, that battery life is something you're continually trying to gauge and trade off. And we didn't really touch on, I mean, your payload is very small. So where you apply these devices, it's about an 11 byte payload. Sometimes you're looking for those quick measurements that you're going to maybe take, we're doing about once an hour, once a day could be fine for many of these. So you're always doing that calculation in terms of, if I want a 10-year battery life, what's my budget? And that gets into the OpEx side, because when you're talking about thousands of devices, changing batteries becomes a very time-consuming activity. So we have to kind of think of it from that perspective. If it's a 30 device deployment, no problem. But if it's thousands of devices, the fleet management and kind of still there's some care and feeding involved, you have to architect from that at the outset.
Yeah, and let me also bring in CBRS again. A lot of the CBRS licenses that Chevron and a number of other energy companies won licenses for last month. That could well be a 5G play, right? It could be 4G LTE today. It could also be 5G in the weeks and months to come here. So that 5G story is quite relevant, really. It provides foundational RF coverage to the field. And I think that LoRaWAN really is the answer to the massive machine connectivity there.
Guys, now there's a question for Scott. How does Orbiwise differ from a network provider like Laureate and others?
Okay, it gets back to the question of the sketch of the LoRaWAN network. Our core product is the LoRaWAN network server, just like Laureate's core product is a LoRaWAN network server. And you have others such as, Actility, Cinet, even the Lens product that Multitech offers is a light, pardon me, Robert, if I'm putting words, but a light version of a network server. So there's all sorts of forms of LoRaWAN network server, and how you offer service around that can be somewhat different. Laureate does offer a kind of a shared server, and you can kind of log on and you bring your gateways and devices and so forth. We offer a similar service, and the others that I mentioned offer this service. So it's good to check out your options. Of course, I would say ours is the best out there, but But there are plenty of options out there on the LoRaWAN network servers, and the kind of network operator or an operator kind of function that you can get to help you run your networks if you're looking for that help.
Thank you, Scott. Next question for the whole panel. In the oil and gas, historical technologies are generally well established and difficult to change. So question number one, how LoRaWAN can disrupt those and manage to quickly penetrate this market? And number two, what are the blocking points for massive adoptions?
I can take that one. So to the first part, I always kind of look at our operator routine duties as that's the opportunity queue, essentially. Things that we've been sending people in trucks that have checklists. Maybe that's a digital tablet now, but it's still a manual activity to get to that site. By prioritizing that list and matrixing it, that's where you can start. This represents all the things that historically were uneconomical to instrument, perhaps. And so that's a great starting point. And we have no shortage on our side, particularly in the wider areas in the upstream. And now I think refineries, plants, pipelines, maybe not so much, but they do still have their use cases and applications. But in the upstream in particular, which is where my expertise is, where my time has been spent, it's really that widely distributed operator routine duty, saving windshield time that we're going after. Blockers or challenges it is still a nascent technology. It's come a long way, but the ecosystem is still shaping. The devices can be a challenge to kind of find and track down. It's not like Bluetooth and Wi-Fi that are very well established, and it's pretty easy to find vendors, especially on the industrial side. You know, there's a few players on the industrial side that are making those class 1 Div 2 devices that are just ready to go, but even they're on a bit of a learning curve. So it's a lot of orchestration taking place at the industrial device level that we have to work through.
The one thing I was going to add to that is just accessibility to data. These kind of, I would say the older technologies that are more established kind of suffer there. And the fact that when you want to solve a problem, you've got to redeploy every time infrastructure, and then you have to maintain that infrastructure, and that can also add up. So for us, I'm looking at it from an accessibility standpoint, but I think the economics really start to add up, and there's a real opportunity to start getting out of these proprietary solutions and getting into where things you have competition. I mean, even to Scott's point with the network server, there's competition there and the consumer benefits. And so you need that to be successful, and you want your technology to have that competition. That helps you. So,
yeah, I mean, really, if you go back to what the slide Philippe showed for the LoRa Alliance, I mean, you've got, I don't know what the exact count is now, but 500 plus member companies. So you have, you know, dozens of options for all of the elements within the LoRaWAN network that you can turn to. And of course, the Alliance is a great reference or great place to go to make these contacts and look at these things. So that kind of answers both of those questions. And it's not kind of like what Josh was just pointing out, you know, proprietary, few companies working with the technology. This is hundreds of companies. That's a big difference, makes a big difference.
I think some of these universal devices that have the capability of powering transmitters that people, you know, process sensors that people are using today is really good at overcoming some of the mental hurdles or the culture piece of it, just because people rely on that. Because if they see something that's, you know, maybe come out of the automotive industry or pharmaceutical, and let's try to deploy this out in the oil and gas patch, there's a good opportunity for it to fail from a few angles, you know. And a lot of times it could be the influence of the operators out in the field doing the deployments. So being able to move forward with this kind of technology with sensors that they're accustomed to and have trusted for a long time, I think really helps a lot as well.
Thank you, guys. So normally we'd be on time, but there are still a few questions. So if you guys are okay, we're going to keep on answering for the people that have the question. Right. So the next question is, in addition to satellite backhaul, has any wide area private LTE network been considered for backhaul, as carrier backhaul is challenging in deep remote areas?
So yeah, we were on that bandwagon in terms of CBRS being an ideal candidate. Funding kind of dried up this year, but that was the direction we were going to be headed, was private LTE, CBRS, use that as the backhaul for the gateways. But that'll have to wait for down the road.
As I mean, we would certainly entertain plugging a couple of different gateways into, or satellite options into our gateways. If it's got a Ethernet or a serial port, would be pretty good to go.
Okay, thank you, guys.
I think there's maybe one more point on that. This
ahead.
is one we've been wrestling with, and that gets to network segmentation. You know, it's ironic we're using the cellular backhauls. We have a great fiber link in a lot of these locations, but we're very security conscious, so we want that physical separation still. How that evolves as we start to move to new architectures, you know, maybe we can reuse some of that infrastructure, but we're very kind of rigid in terms of there's a hard physical separation between this kind of fast path for lower consequence measurement and the traditional networks in the field. Maybe in time we'll see how those get married together without having to build a lot of new infrastructure. But
good point. Thank you. Another question. Often the business case fails because the infrastructure costs such as gateway, network server, and cloud are all taken into account for one typical use case. How can you get around this?
So I don't mind jumping in there. I mean, I spoke to this a bit during the conversation. A lot's changing in the US. It depends on where you're deploying. Certainly other countries, that gateway infrastructure may already be there for you to leverage. Within the last, I think, month, Amazon Echo is kind of announcing that they're going to be including LoRa into that. And we certainly have public and carrier grade networks being deployed in the US kind of rapidly. So we're seeing that change now. Will that make its way to helping these use cases out in the areas that these particular, deployments are of use? That'll be the question. And that is challenging, but I think we're also seeing gateway costs drop pretty rapidly as well. Not to Robert's benefit, but certainly to competition. So I'm poking fun there, but it's generally we're having competition and it's moving in the right direction. So
I think that's a great question. So it was a pain point for us early on, and that was, I'm going to focus on the application layer in particular, where we saw the walled gardens. Everyone was taking LoRa, hacking it, making it work for themselves, and it worked for one use case. So here's your gateway, here's your app, here's your whole thing, and then you got to rinse and repeat for every solution. So that wasn't tenable. That got back to owning the core. Our focus now going forward is really, again, on open standards, and it was alluded to earlier, where we really want to see an alignment on these MQTT pub sub models. The spark plug specification is another open spec that Chevron is supporting, and we're working with vendors to say, okay, this is the standard that we want the industry to kind of start working towards. It's an open standard. It's managed by the Eclipse Foundation, so that we're just publishing and brokering data using that standard instead of custom application layers for every little solution out there. It's just self-defined kind of message payloads using MQTT, well established at every level. That's kind of where we're going next as we think about scaling across a heterogeneous set of opportunities before us.
Yeah, I think talking about the business case, and I'm thinking back a few years to working with a major U.S. operator and trying to pitch LoRaWAN, and their analysis in the end, and they ended up not wanting to really do anything with LoRaWAN, but it wasn't because of the gateway cost or the network server or the devices. In fact, those costs in their analysis were actually very, very good compared to the cellular options. The hang up they had was more on the installation, getting unionized labor to go in and install stuff on a site. Things like that was really, in the end, what killed the opportunity. Now, I'm not going to get into cellular's costs and so forth, which has the same issue, but really, if you look at the cost of this, and especially in oil and gas, I think a lot of the companies in this space, you control your infrastructure and so forth. So your costs, you should be able to really keep those down. So anyway.
Thank you, guys. So I think we're arriving at the last question on the list. is there any common protocol that can be used much as the ART Foundation has defined? So really focus on command protocol.
I mean, the LoRaWAN is a common published protocol. I'm not sure. Maybe the question is has to do with standardization of the payload from the sensor. I'm not sure.
So, I mean, personally, when I'm looking at that question, I would interpret it as, okay, we talk a lot about sensors, getting data from the field. I think the command is, okay, can we activate something remotely? I think that's the way I would look at it, right?
Yes, for sure.
But maybe I'm wrong. So if I'm wrong, let me know.
So,
but yeah.
Yeah, so if the question was about writing a command to like a discrete output to open or close a valve or something like that, then yes, you could do that over LoRaWAN.
Yeah, and if it was perhaps around the standardization, that would be the other element that I think LoRaWAN is still growing and it's still evolving. I don't know if you're familiar with Zigbee and those kinds of technologies where we have, particular device types and how they interact. We're not there yet, but we're getting close. But you do see a lot of synergy and attacking these things in a common way. And I still think that's yet to come. And I do think we'll get there as far as the alliance is kind of targeting long term. But right now, as Rob mentioned, it's a lot of that can be obscured through applications, though. So you don't have to worry about how you're interacting with that device. Those application layers and device drivers are built for you. But if you do want to go, given that it's an open standard, a lot of times it's published. So you can get all the way down to the nuts and bolts and know exactly what commands you need to send to cause it to do something. And you can set that up on your own as well. So to me, that's just leveraging that openness of everything.
Yeah, the idea of a LoRaWAN kind of payload standard was something near and dear to our hearts after wrestling with a lot of different vendors.